Thanks for joining. We are inside day number 2. Today, what we are going to learn about the SD-WAN components, their features, what are the capabilities we have with these SD-WAN components, their hardware form factor, their software form factor, and basic few lines of configuration in the controllers and in the devices. So that's the target that we are going to spend in next 60 minutes or 65 minutes. All right. So as we know that we have two components, we have something called controllers or group of controllers, and we have something called the edge devices or the branch edge devices, where we may have Cisco ISR routers or Cisco devices term as a C edge, or we may have Viptela devices term as a V edge. Now, in upcoming days, in upcoming slides, I will show you more about Cisco products, how they are supporting Cisco SD-WAN overall portfolio. But today we'll go and see the basic things, basic components and all. But later on, obviously, I will go and show you some more products as well, which is supporting SD-WAN. So here you can see in this slide that you have vManage, vSmart, vBond, and vEdge devices. The first three, they are nothing but the controllers. And the last one, here I have mentioned only vEdge, but we have C-Edge as well. C as a Cisco Edge devices. The first three, they are the controllers, and then we have the actual edge devices who is doing the data forwarding. Now, these are the controllers that is very much software based operating system. So we can go to any compute. Mostly we are using it over the ESXi hypervisor, but you can use any suitable compute. Even you can use cloud hosted compute as well, like Google or AWS, etc. And you can install these controllers. Later on, when we'll go and discuss more about the controllers deployment, so we'll discuss more about their deployment and the deployment models, either it's on-prem or it's over the cloud, etc. Okay, but suppose if you want to make your in-house SD-WAN fabric, or suppose if you want to make your own lab, so you need such type of facility where you can go and spin up the vManages. That is means you want to spin up your management plane, then you can go and spin up your other components like vSmart, vBond, etc., etc. Okay, so you can see vSmart, you can see vBond. Now I will go and draw something very interesting here, and then I will show you everything in the slide. So if I go and draw one chart here, and starting with vManage, vSmart, vBond, because all these are nothing but the networking components, right? These are the networking components. That means that suppose if my controllers, they want to communicate with the edge devices, they should have the reachability to the edge devices. Or suppose if one controller wants to reach to other controller, obviously they have some reachability in between them, right? And obviously there is some limitations as well, that how far your controllers should be. Those limits and other things we can discuss later on in the maybe advanced topics, when we'll go and touch the controllers deployment and their best practices. Then we'll go and touch Cisco sites to see that what should be the minimum latency in between vManage in a fabric, vSmart in a cluster, etc., etc. Okay, we'll see that. Actually, they are in a group and they are in some sort of cluster, and they have some sort of DNS in between for high availability and redundancy. We'll see that later on. All right, so these you can go and install over any compute for your home lab, you can go and use VMware Workstation. Otherwise, in a production environment, they will be over any hypervisor, maybe some servers. On top of that, you have the hypervisor, and then on top of hypervisor, you're installing these VMs and these softwares as a VM, right? So now, if I go and utilize the VM, this is the Viptela manager. So what are the requirement we have? Since they are virtual, right? Since they are virtual, that means they need some sort of VNIC. Okay. And later today, I will explain you this thing that for the controllers, because controllers.
Is that VNIC? Did you write VNIC?
VNIC,
VNIC?
VNIC,
Okay,
yeah. Sorry for that type. So VNIC, virtual NIC. Okay. I will come to that. Let me erase and write it properly so you can see this. This is VNIC. Okay. So the point here is this, that later on in this, today only, later on, I'll explain you that there are certain VPN, like VPN 0, VPN 1, VPN 2, VPN 512. Those VPN are nothing but the VRF. So we have some concept of virtual private network, but they are actually the VRF. So starting with Viptela, Viptela came with this idea of VPN is nothing but the VRF. Then Cisco, in Cisco devices will find this VPN is nothing but the VRF, right? Logical separations of your routing table or your interfaces, etc. Correct. So in the Viptela devices, we have certain purpose-built VPN. So if any interface, they are part of VPN 0, they will termed as a WAN facing interface. Okay. So if you are connecting your interface to the WAN side, those interface should be inside VPN 0. Okay. And suppose if you're connecting your interfaces towards LAN side, and that VPN is starting from 1 to 511, for example, then these are nothing but the service VPN. Okay. These are service side VPNs. And if you have any management traffic, you can go and connect with VPN 512. That will be your management VPN. So this VPN 0 is nothing but the transport VPN. VPN 1 up to VPN 511, that is nothing but the service VPN. And any management traffic, obviously you need some out of band management traffic and all to reach out the device. So that interface will be part of VPN 512. Generally, these are the Ethernet interfaces. The rest of the interfaces mostly you'll find as a gig interfaces. Okay, so you have one box, you have one router, and then in that router, you're creating certain interfaces, right? So those interfaces, if it is facing to WAN, what is that name? That will be?
Facing what? Say that again.
So purpose-built interfaces are there. And if that interface is going towards WAN, so what will the name of that interface? WAN side. It will be under VPN 0, right?
Yeah.
And VPN 0, they are termed as a transport VPN. Okay. So VPN 0, any interface that is part of VPN 0, suppose this is gig E0/0, this is transport VPN. The name of this VPN is transport VPN because it is part of transportation. If any VPN is starting from 1 up to 511, that will be part of LAN side VPN. So these are nothing but the VPN 1 up to VPN 511. They are termed as a service VPN. Any doubt in this name? just the nomenclature, just the name.
Mhm.
Then we have one extra VPN. That VPN is what? VPN 512. The name of VPN 512 is nothing but the management
Management.
VPN.
Mhm.
Great. So this will be one of the question that I'm going to ask you in the multiple choice question list when we have the test, maybe whenever we have next to next class. So this will be there as a multiple choice. Okay, transport, service, and management, right? Okay. Now coming back to our diagram that we have here, think like this. When you'll go and draw the diagram, I have some. Okay, when you go and draw the topology, and I'm not showing you any standard topology at the moment, any architecture. What will happen that your controllers, vManage, vSmart, vBond, etc., they will be somewhere. Maybe, for example, think as a cloud, or maybe somewhere in data center. And then you have your edge devices. Now you can think about the complexity here. The complexity or the diversion that we have here is that these are the hardware devices. So these devices, they have some gig interface 0/0/0. They are connected with either MPLS or they may be connected with internet, right?
Mhm.
Then it will go somewhere to the data center where you have some core routers, maybe non-VPN routers, and then this internet or MPLS link, they are getting terminated. Or maybe you have some Viptela core routers, not only not only non SD-WAN, but it may be SD-WAN router in the data center also, Viptela routers or CH routers, and then the connections are terminating. So all these edge devices that we are seeing here at the moment in this diagram, they are the hardware based device. They have physical interfaces, they are connected with ISPs or switches or firewall, etc. Right? So
Mhm.
whenever you have any router, they are connected with the ISP, and the interface we are telling this as a physical interface, right? My physical interface gig is 00 connecting to the ISP. They are connected to ISP. But if we have any software which is installed over any server, right? In case our vManage, so it's a software, right? It is installed over any maybe any server, any Dell server, anywhere. Now, when it will go and connect, where it will go and connect? So it should have some switching network or maybe router physical network where it will go and connect. Correct?
Mhm.
So what will happen that behind the scene, your vManage actually will go and connect with the vNIC. Okay, with the it will be mapped with the uplink, physical uplink of that server, right? So in the example that I'm telling you here, if you go and see this example, this vNIC actually behind the scene, it should be mapped with some physical link because it has to go and connect to with the ISP. Correct?
Mhm.
And in VMware world, I think we are telling this as a VMNIC, VMNIC 0 or maybe VMNIC 1, because if you see the VMware world, if you have done this study, suppose you have any Windows operating system over the hypervisor. So obviously one of the port, I don't know how much you know about the VMware world, but in VMware world, uh, there are something called vSwitch or DVS, distributed virtual switches, or VSS, virtual switches, and there are interfaces like management interface, like physical interface or VNIC interfaces, etc., etc. So any interface that is going towards the uplink, towards the physical infrastructure. that will be mapped with the physical interface, and at the moment you think this as a virtual NIC, simply virtual NIC, because we are not going in that much detail. So you have any doubt understanding this?
No doubt on my
No.
side.
All right, so the question here is this, that if we have the vManage, right, how many vNIC we need for vManage?
One.
Okay, you can think only one.
That depends if you want high availability. So let's say you can have you can create not to change topics, but you can create a cluster of three, or so it depends on the customer requirements.
All right. So because we are a little bit ahead of time, so maybe you are not able to figure out. No problem. Do I have any other? Okay, I will come back to this diagram as well. So what I'm telling here is this. Let me clean this and okay. So what I'm telling is this, that think your vManage as a physical device, for example.
Mhm.
Okay. So obviously you will go and connect to your VPN 0 interface where
Mhm.
facing towards WAN side. Why? Because if they are facing towards WAN, then only they will go and form the tunnel with the edge devices or other controllers, right?
Mhm.
VH, VH, VH. So that means you need at least one interface that will go and connect to the WAN, correct?
Mhm.
Then you need one extra interface for management, right?
Mhm.
So that will be VPN 512. I'll write VPN 512. So that means for all the controllers, you need at least two virtual interfaces, because these are
Mhm.
software. We don't have physical, we have virtual interfaces,
Mhm.
correct?
Yeah.
Minimum requirement is two. Now, if we are talking about the high availability criterias, high availability criterias means if you go and see Cisco ACI or NSX-T controllers, control plane, or any type of controller, you'll find that one is not enough. And there are some number, if we go and study more about vManage, so it will tell that one vManage can go and hold up to 2000 edge devices. So suppose in some infra, if you have 4000 or 5000 VS devices to manage, that means obviously you need more than one vManage, right? So the point here is this, that if we go and club these vManage in a cluster, so how these vManages will communicate to each other? So that means they need one extra shared vNIC with some shared LAN in between them, right?
Mhm.
So that means that if you have a vManage in a cluster, in that case, how many vNIC you need? You need
Two.
3 vNIC. Okay. Any doubt in this? Please feel free to
Mm.
ask if you have any doubt.
Hey, I got a question. Okay,
Yes,
go back to
please.
that other slide you had. The You said
Yeah,
it was you need one management and one for, go back, not that one, the one you drew, go back,
this
this
one,
one.
this one. Okay.
Okay, yeah, so you said you needed one physical for the WAN, right, that goes to the cloud, and then you needed one for 512, right?
Management. Yeah.
Yeah, okay, so then the one example where you said you have 2,000, what if they needed 4,000? Do you need two VPN 520 and an additional WAN link to that? Do you have to increase that, or does the two that you have is enough?
Yeah. So the WAN connection is one, that's fine. What I'm telling here is this, that to handle the to manage 2000 devices.
Mm-hmm.
Manage 2000 devices means 2000 devices control connection,
Mm-hmm.
2000 devices configuration, running configuration, 2000 devices application status and all. Everything we can manage from vManage, right?
Mm-hmm.
So to manage the load and the attributes of 2000 devices, we need one vManage. But
Okay.
suppose in a infra, if we have more than 2000 devices, then obviously
Mm-hmm.
we need more vManages. That's the
Mm-hmm.
one reason. The other reason is this: suppose if we have only one management plane, and if somehow it will get reboot or unavailable, so obviously for high availability we need more vManage in a cluster,
Mm-hmm.
right? So that's why now if you form the cluster, you need extra interface. So
Mm-hmm.
that's the reason for that's the reason for vManage. We have three unique requirement.
Mm-hmm.
So here how much you need? Here you need two VNIC. Here also two VNIC is enough. And VEdge. Now tell me about VEdge. It's a hardware here. And for VEdge, how many VNICs are required? So minimum two is fine, like connecting with WAN and the management. But isn't the VEdge that we have, right? Suppose this is VEdge, which is going to connect with switch somewhere, because
Mm-hmm.
behind the VEdge we have the LAN infra.
Mm-hmm.
So that means that there you have, okay, to bring up the fabric you need only two, but for VEdge you may have more than two NICs. These are
Mm-hmm.
the NICs. These are the physical interfaces. More
Mm-hmm.
than two. So more than two, like greater than equal to two. In this line number one, item number one, if you have any doubt, please feel free to ask.
No, no
Mm-hmm.
doubts, my side.
All right. So before going to item number two here, I'll do one thing. Quickly, I will show you the vManage capabilities as well in the slide. So what vManage can do, we know these things quickly. Within 2 minutes, I'll cover. Centralized management, REST API. You can go and integrate with REST API. And good news about this, I'm going to start very soon the DevNet curriculum as well, CCI DevNet course. So I'm working on that, creating lab and everything, where it makes sense that what is the REST API, how the CI/CD pipeline working, how the Dockers are working, how the programming is working, how you can go configure ACIs, vManage, and all those things. There is that is a big area, and that's why Cisco has introduced DevNet. I can say that at this point of time, it is not one of the popular CCI exam, because whoever have done their job from last 10-15 years, they are not good in programming. They have never touched Python and all and all. Whoever the new brand of engineers are coming, you can say that next generation engineers, so they're coming, they're making their mind that they have to do the programming and all those things. So they are coming and they are doing all these things. But down the line, you will see, down the road, you'll see that we also have to go and at least know that how things are working behind the scene. All right. So at this point of time, if you go and learn any SDN solution, you'll find that they have API, one interface called API, Application Programming Interface, from where you can go and manage the entire fabric. Now, if someone knows API, the point here is this, that he can go and manage the entire business. Entire business means he can manage the LAN, because DNA understand APIs. He can manage the data center, because ACIs, Epic controllers, they understand these APIs. They can manage WAN as well, SD-WAN as well. Even non-Cisco products also, they are API aware. So one engineer will become very valuable, although he don't know fully behind the scene how technology is working, but with help of API and a script, he can do the job. So that's one of the power we have with the API. So vManage can do centralized management, REST API integration, configuration management, monitoring, and management. So these things we know. Later on, when we'll log into vManage and we'll do more and more operation, this will become much more visible. Okay.
Mhm.
All right. Then what is the role of VSmart? This is the brain. I told you earlier, this is the
Mhm.
brain in the fabric. It can go and do the routing decisions. It can go and do the key exchange. It can go and do create the IPsec tunnels. Means with help of VSmart key exchange, IPsec key exchange, it will form data plane devices. They will go and form the IPsec tunnels. It can go and do the VPN policy management, service chaining, traffic engineering. Means all sort of intelligence we have, routing intelligence we have. We need VSmart and VSmart policies. So this is the policy maker. And finally, VWAN, as we know, that's the orchestration. It will bring up or tear down the fabric, and it has one IP which is reachable to the internet. All right. Now coming back here, point number two. Point number two is very interesting, and this thing I'm keep telling in all my sessions that what's the what's the difference you see in between WAN and SD-WAN. I'm telling that okay, the SD-WAN is a network where you have the database. So now we have database related network. Earlier we have normal network. We don't have any centralized database. So in this controller where we have the database, obviously we have database to the vManage. vManage having database. Cisco ACI Epic controllers, they have database. NSX-T controllers, they have database. Whatever controllers we have, they have database. In that database, what they are storing? Configuration files, certificates, statistical informations, network information, and etc. Right. So if you go and see the vManage deployment guides, you'll find that for a small lab type of environment, you need only 50 GB database. For bigger environment, you need 100 GB, 500 GB, etc. It depends upon how many routers you are managing, what is the size or the scale of network. According to that, we are choosing the database. Other controllers, do they need database? No, they don't need. Right. Third point, what we can say here. So it's a centralized management and all those things that we have seen on the slides. It's the intelligence, like it's the brain in the fabric, it's the orchestrator, and it's the actual data plane device, right? So your vManage is the management plane, actual management plane. vSmart is actually your, you can think as a policy. This is also a control plane, but it's a policy maker. And this is nothing but your orchestrator plane. Okay, any doubt in this? It's fine.
Mhm.
Great. Good understanding. So let's quickly see all these slides. So all these slides we know. These are the theoretical slide. How this VH look like. Later on, I will show you the Cisco devices as well. This is VH 1000, VH 500, etc. Now in these devices, because um, because it is evolved, we can think that behind the scene all these engineers, they are working in Cisco. They they created their own company and then they developed all the product in China. So the basic hardware, the chassis, the look, feel, etc., etc., most of the things you will see that it's very much Cisco type. And most of the devices, maybe even Brocade or maybe Arista devices, you'll see the CLI is very much like Cisco type, conft and all and all. HP having some different, Dell having some different CLI style, even Juniper having some different CLI style, but VH is very much, you can go to conft and do the configuration and all, we'll see that. Behind the scene, you can see this interfaces and all, management interface and console port and USB ports and LED status, and then you have some Ethernet module, 8-port Ethernet module inside this VH1000, etc. Everything is very much Cisco style. The only new thing you will find in VH and nowadays in CH also is something called TPM chip. Let me highlight here in the bottom. TPM chip. This is Trusted Platform Module, TPM. TPM chip. So what these vendors they are doing, that they are putting all sort of certificates inside the TPM chip, and then they are shipping those devices to the customer premises. So customer will go and connect their WAN interface, and if we have some sort of plug and play behind the scene in picture, then these devices will go and do the authentication with vBond, then vSmart, vManage, and they will join the fabric. Okay? So all the vendors, they are making these devices ready to ship, but they don't want that in between it should be compromised and all. That's why they are putting some sort of certificate inside the TPM chip. Now for yourself, if you have time, you can go and check the difference between TPM, Trusted Platform Module, and TAM, Trusted Anchor Module. TPM is there inside the VH, and TAM is there, Trusted Anchor Module is there inside the C-Edge devices. What this TAM is doing, again, same thing like anti-counterfeit and security and authentication, etc. I also have slide. I will show you. I have 1 or 2 slide, but if in your time, if you have time, you can go and have a look, a small look, do little bit Google, learn what is difference between TPM and TAM. Then you have the high-end devices, VS2000, VS5000. Nowadays, these devices are, Cisco is supporting these devices, but they are not manufacturing these devices. Cisco don't want that customer will go and use these devices because they are supporting their ISR devices. And again, in the upcoming CES slide, we'll go and check the ISR devices. Generally, we'll see that Cisco ISR devices, they are coming with something called iOS XE operating system, but some of the product is there in the market. Cisco is doing manufacturing those products. They are coming with Viptela OS as well. So whatever devices we have seen so far, VH, 500, 1000, 2000, etc., they all have something called VIP OS, Viptela OS. Viptela OS configuration is quite different than the iOS XE configuration. And you can think like this, that the iOS XE was not developed as a SD-WAN operating system, and that's why initially Cisco has faced so many challenges, because what was the idea, idea? So Cisco has acquired Viptela company, and then they start telling their customers that, see, since you guys are using our ISR routers or ASR routers, so if you go and migrate your SD-WAN, you don't need to go and purchase new hardware. You think this situation, a customer having 4,000 ISR plus ASR devices, and all of a sudden that particular customer or that company decided to move from WAN to SD-WAN. So if they go to pure SD-WAN, maybe some other SD-WAN, maybe Silver Peak, etc., that means they have to retire out all those 4,000 devices, right? And then they have to go and purchase Silver Peak or any other company hardware, right? So in this case, what Cisco is telling to the customers that, okay, do not retire your devices. In your device, you can upgrade the image, some iOS XE 17 or maybe 16 or 17. Once you go and upgrade the image to iOS XE, that particular image will go and support Viptela. But if you go and check the iOS, the any type of operating system, how they are built. So operating system, the low level language is something like kernel, level programming, and on top of that they have some other high level level languages like user space and all, and on top of that they have instruction. So behind the scene what is happening, each and everything, whatever instructions we are giving to the system, they are actually coming from the operating system, from the kernel program. So everything in a system actually they are glued with the operating system. Now, since this iOS XE was not evolved as a SD-WAN device, as a SD-WAN operating system, so what happened with Cisco, that you have some space in your router where you have iOS XE, and then here somewhere they have put some sort of SD-WAN code. You got my point. Like you're writing one program, one big program. Suppose this is your operating system program. In that you don't have any SD-WAN awareness. Then once you upgrade the, once you go and upgrade the operating system, then you are adding some more lines, and that those more lines are nothing but those lines of code are for SD-WAN. So this is called patching. You know, you don't have your parent configuration, but that configuration is coming via some patch update or something like that. So that means that iOS XE devices, they are not true SD-WAN devices, and that's why Cisco has faced so many challenges. And that's why in day one I told you that SD-WAN doesn't mean that simply you are using internet link and job done. It should be intelligent, it should understand application, and all those intelligence behind the scene. This Viptela, on other hand, it was SD-WAN device. It can do application optimization. It is very easy to use, lightweight and all. So that's why Cisco has started creating ISR with the Viptela operating system. Okay, so I hope you understand the history behind this and how the things are evolved and how things are moving. Few of the customers at that time, maybe 2 3 years back, what they have done, they simply purchase only Viptela devices, this VH500 or 1000 and 5000, because anyways after 5 years or 7 years, all the banks, all the corporate network and all, they are retiring, they are refreshing their hardware. So in the hardware refresh cycles, they start using the Viptela devices, the VH devices instead of ISR devices. And now again they are changing to the native ISR with the Viptela devices. Okay, so that was long story. Sorry for that. So far, if you have any doubt, you can ask. Got it right? Great. So these are normal networking things that you can refer, and these are normal networking things that you can refer. Just the informative slides.
Can you hear me?
Yep.
Will you be posting this video on YouTube as well?
Answer is yes. Any problem in that?
No, I just asked that you send us the link because that's actually something we can review at work
100%
if you
right.
put on YouTube.
Yeah, this video also I'll post on YouTube because this is also informative video, so I'll put that. All right, let's move on now. I'm going to show you one very important thing here. This thing, then we'll come to the topology. So far what we have discussed this thing that you have controllers. What are the characteristics of controller? Someone is management, someone is the intelligence, someone is orchestrator, someone is doing actual data handling. What is the physical interface requirement? 3, 2, 2, at least 2, etc. Whoever having the database, we manage. So you need some sort of data store while bringing up or while doing the deployment, and then the characteristic of those devices. So now we know the role and responsibility of the devices, and we know the minimum requirement to deploy that device. Later on when we'll do the deployment, it will be much more clear. So now let's go and try to draw the diagram with very less number of devices, and we'll try to understand more about the control plane bring up and the data plane bring up. So I'll go and draw the diagram here. Let me use the color. So I have my vManage somewhere. I have my vSmart and I have vBond. And I'll go and use only two vEdge. Suppose vEdge1 and vEdge2. And suppose we have two ISP, ISP1 and ISP2. Maybe internet, maybe MPLS. At the moment, we'll not think about that. All right. So as per our knowledge, whatever we have studied so far, that first of all, the phase one, your control plane bring up will happen. So control plane, that means your vManage, vSmart, vBond, you have to go and bring up your control plane. So if they are also connected via ISP like that, so then they will go and form some sort of tunnel in between them. I'll go and specify the tunnels in between them. But the tunnel, the control plane tunnels that they are forming, they may be DTLS tunnel or TLS. Maybe transport layer security or dynamic transport layer security means this is something called TCP based SSL, and this is UDP based SSL, right? And how SSL is working, the certificates behind the scene, you can check. It's not very difficult. Anyways, later on we are going to check about that. So you will see one thing here to note, that this vBond that we have, they will always 100% of time they will form DTLS tunnel. But for the rest of the devices, either it's a vManage, vSmart or vEdge, they have option. Like we have the option, we can go and choose either DTLS or TLS. Okay, so that means that once you have the control connection, and I'm using red color for control connections. So once you have the control connection, so your edge devices will also go and reach out the vSmart via 2 ISP. These are the control connections. I'm not drawing the control connection for, okay, just to make this simple, I'll do one thing, I'll erase this. So red color is for the control connection, right? Either it's a DTLS or TLS. In case of vBond, 100% of time, this is nothing but the DTLS tunnel, right? Now, obviously, if you do not have routing reachability, if the edge devices or the controllers, they are unable to reach among themselves, they will not form this control connection, right? So overall, this is nothing but the control connection. What protocols are working behind the scene, we'll go and see. In this particular diagram, do you have any doubt? It's very easy, fine. It's no problem. Once you go and watch this video, you can go and draw a similar diagram like that, because it is going to be complicated now. So if I go and draw vEdge 2 here, and for vEdge number 2, if I go and draw the control connection to reach both the ISP, obviously you have the control connections. Even for the vManage also, I'm drawing two connections here. Now, when we'll go and learn this little bit more, there are some changes as well, we'll come to know. But my question here is this, that for vEdge1, how many control connections you have? How many red lines you have for VH1? 4, right? You can see 1, 2, 3, 4, right? Any doubt in this, right? You are still there?
Yeah, 4. I think I had my mic on mute. Sorry about that. Yeah.
Like 4, right?
Yeah.
Okay. And here you may ask me one thing, that to reaching out VBond, why you haven't drawn any control connection? Okay, so later on in this course, you'll come to know that VBond is an orchestrator plane. While bringing up the fabric, they will go and create the control connection, and then they will tear down the connection. So what I'm telling, that with VBond, we don't have permanent tunnel, although we have something called temporary tunnel. Permanent tunnel is not required. It will go and form while we do the authentication, while we go and deploy the controller. After that, this tunnel will be tear down. It will be removed, this blue tunnel. So that's why I haven't done that with the VBond. That's one very important thing. Okay. The second point here is this, that to reach to the VSmart, suppose if you have two ISP, to reach to the VSmart, you have to active tunnel. So there is no problem in that. But to reach to vManage, mark my words, to reach to vManage, one tunnel will work as an active, other tunnel will work as a standby. So that means if item 1 and items, let me see that which is going to the vManage. So this and 1. So, okay, 1 and 3. Okay. So suppose if tunnel number 1 and tunnel number 3 is reaching out to vManage, either 1 or 3 will be down. You will see only one tunnel. So I'll remove down this one. You don't need two active tunnel to reach vManage. If somehow if 3 will go down, then 1 will come into the picture. So that means that with vManage, for optimization sake, by default, you have active standby tunnel. Okay. With whom? vManage. With vSmart, what you have active tunnel. This tunnel are nothing but DTLS or TLS connections, right? And with vBond, you don't have tunnel. You have temporary tunnel, and then you will not see that tunnel. Okay. So within one small diagram, you can see how many things we have learned. Okay. So many things we have learned, right? So this is all about control plane tunnel. Now, what about data plane? So data plane tunnel, how many ISP you can see here? You can see here 2 ISP. So that means 2 IPsec tunnel. So this yellow is nothing but your data plane tunnel. So here you can see that you have 2 ISP. That means you have two IPsec tunnel, right? And how it is forming and all this long theory behind the scene we'll understand. Now you can see full-fledged SD-WAN diagram. The architecture, you can see that architecture of SD-WAN, where the controllers, what control connections you have, the data plane, what data connections you have, how many active, standby, etc. Those type of scenarios, the UDP and TCP. So in this diagram, at least you can mark out point number 1, that vBond is always forming the DTLS channel 100% of time. Apart from vBond, all the SD-WAN components, they either can form DTLS or they can form TLS. Now, when it is coming to edge devices, when they are forming tunnel with vManage, so only one connection is active. Rest all the control plane connections are standby. If active will go down, then standby will become the active. In case of VS Smart, they have active connections because you all the time you want to reach to the VS Smart. You can go and add more complexity. If we have suppose 10 VS Smart, so then how the connections are working and all we'll see later on. And then we have VBond. With VBond, we have actually no tunnel. It will be there initially as a temporary tunnel. Once VBond will go and authenticate these devices with the serial number and the chassis ID, then those tunnels will get terminated, and then they have the permanent stable connection with the other controllers like vManage and vSmart. Okay, any doubt in this? Now if I go and show you this diagram, you will understand this fully, this diagram. So you can see here in this diagram that these are your IPsec tunnel forming, and then you can see these are nothing but your control connections going from edge to controllers. These are either your DTLS or TLS. And then in between the controllers, you can see in between the controllers, you will see that you have something called either DTLS or TLS. And here you have DTLS. Okay. All right, so let's go and check this diagram. Suppose if this is our lab diagram. In our lab that I have shared with you, in that I think only one DC is there. So at the moment you think that we don't have this DC, but later on we have some other labs as well. You can focus on this area, that one DC and two branch. And if you go and draw out the tunnels, so like this, you have the control connection for this. If two ISPs there, like here is some T-lock extension and other things are there. So I will not draw here. Later on, we'll discuss more in the um, overall the IP address schema and all, and the lab and all. Okay. So far, if you have any doubt, please feel free to ask. All right, if no doubt is there, then today we have a study a lot in last 45 to 50 minutes. We have a study a lot, and next thing that we want to do is that we want to bring up these devices in our home lab. Obviously, I will go and show you everything. Before that, we'll go and discuss about how to bring up these devices. I have the notes and the labs are there. We will check that. But if you want to bring up the devices, what are the steps required? These are the steps. I will go and explain all these steps. So there is no problem in the steps and then all the theory and the lab. Let me go and pause the recording.